if you can see here, this is what we are doing. We are done with these two sessions. Today we'll see acid properties, and tomorrow we'll see the connection establishment, and then it's going to be the installation. And during the installation sessions, before we begin our installation, I'll set up the lab in my environment. So Akim, for you, installation will happen only after 2 days, and until then it's just like a theory concept, right? And probably technical session is this one, connection establishment, and today is also kind of a technical and non-technical put together, right? Day one, interrupt me anytime. There is no concept key. Question and answers should be at the end of the discussion. You have any questions, you just interrupt. ACID, first thing first, Postgres claims that it is an RDBMS technology, relational database management system. To claim one database software as an RDBMS, it should satisfy SQL and it should be ACID compliance. SQL is a language you use to communicate with your database. So if you are claiming that it is an RDBMS, you should follow that language. Select star from employee is the query that you use to get the data from employee table, and it should work in any RDBMS technology. So when I do select star from employee in PostgreSQL, it should work. I got it. Number two, it's ACID compliance. What is acronym for that? Atomicity, consistency, isolation, and durability. So this is the acronym for ACID: atomicity, consistency, isolation, durability. It should satisfy all these properties. What is atomicity? Atomicity stands for irrespective of the number of transactions you have, treat it as one. For example, this is the basic example. You're sending money to your friend. For example, employee 1, he has some 400. Employee 2, he has some, let us say 200. And employee 1 want to send data or amount to employee 2. Then what should happen? First, amount is deducted from your account and is credited in your friend's account. Basic transaction you do, right? You purchase something from Amazon, amount is deducted from your account and credited in your in the Amazon's account. So to send a money, these two things will happen. Update employee, set salary equals to salary minus 100 where ID equals to 1. And the second is plus 100 where ID equals to 2. This is what happens when you send money to your friend. And what atomicity says, irrespective of number of statements or statements you have in a single transaction, treat them as one. Here I have two statements. What atomicity says, either execute both or execute none, but it should not be like executed first successfully and second failed. For example, if The first is executed successfully, amount is deducted from my account, but is not credited in my friend's account. This is a failure transaction. So if for some reason first executed successfully and second failed, roll back your first. That is what atomicity says. You'll get your money back after some time if something goes wrong with your transaction in Amazon or Facebook or Flipkart, whatever it is. That's acid, atomicity. Consistency, there is no specific definition for consistency. If your database is satisfying atomicity, then it should be consistent. Before and after your transaction, your database should be same. For example, it's again a simple one. 4 plus 2, 600. After a successful transaction, it is 3 plus 3, 600. After a failure transaction, it is 500. Before and after my transaction, there is no consistency. There is some consistency missing after a failure transaction. This is a failure transaction. As long as your database is satisfying atomicity, it should be consistent. So you need not worry about the consistency. The third one is isolation. Before and after your transaction, it should be consistent. Simple. What is isolation? Reads and writes should not interfere each other. And reads should always see the consistent past image. So this is your isolation. For example, I'll come here. Yeah, any question? See here, what I'll do, select star from employee. I have salary 500. Then what I'll do, update employee set salary equals to 1000, where ID equals to 1. I'm just changing the salary. I'm updating something, but I have not committed this. I just try to modify something, but I have not taken any decision whether to confirm it or not. Meanwhile, I'll try to get the data from the second machine, sorry, second session. I still see 500. I try to modify here. At the same time, I wanted to see what is the data. I could still see 500. The reason being this one. Reads and writes should not interfere each other, and reads should see the consistent past image. So the consistent past image is 500. So I will see 500 only. When I try to commit it, I got a commit complete message on my screen, which means I have confirmed this change. After confirmation, I will see the data. 1000. Update it to, let us say, 300. I will still see the consistent past image 1000. My select is not interfering with my update. My read is not interfering. When I try to update the same thing, it will not work. reads and writes should not interfere each other, but write and write conflict will be there.
So there is a lock. Is this what has to do with
There is an exclusive lock happens, yeah.
does this has what has to do with small dimension concurrence?
Okay, I'm not getting what you're telling, but yeah, your update takes an exclusive lock until you commit or roll back this transaction. It holds the lock.
Okay.
Now let us say I'll commit this. This is also committed. I mean, this modifications has applied. Any question in isolation?
Okay. Has this got to do with motivation concurrency control?
We'll understand concurrency control later. Yeah, but yeah, this is the concurrency handling. Okay. Any question? Durability says at any cost my data should be safe. So your database software should do that. At any cost your database is safe. Okay. PPP, are you trying to say something? Okay.
No, sorry. I just accidentally
Huh.
clicked on this make button. Sorry.
Okay. Yeah, not a problem. So these are your asset properties. Atomicity, irrespective of number of statements in your transaction, treat them as one. Consistency, before and after your transaction, your database should be consistent. Isolation, reads and writes should not interfere each other, and reads should see the consistent past image. Durability, at any cost, your database should be safe. This is the general asset properties. Now, how Postgres achieves all these things? First one, Postgres achieves atomicity with the concept of begin and end. So you put begin, which marks the start of the transaction. Clear? Begin. Sorry, login. This is this is marking as a start of the transaction. I execute the first statement. I execute the second statement. I execute the third statement. Now you issue commit. As long as your session is not seeing this commit message, you are in a transaction mode. And if something goes wrong with your second statement, it will roll back your first statement. This has executed successfully, this has executed successfully, and this is failed. If that is the case, it will roll back this and this, as long as you are in begin and end block. You can also use begin and end. Begin marks the start of the transaction, end marks the end of the transaction. Select star from employee. My current salary is 300 rupees. Now let me change it to let us say 1300. I'll open. It's 1300. I'll try to commit. There is no transaction in progress. If you are not putting your transaction, or if you are not enclosing your transaction in begin and end block, Postgres is by default auto commit. For example, if I come back here, I have 3 statements to execute. I did not put it in begin. So it treats them individually. It treats them as individual transactions. So you cannot roll back your first and second if something goes wrong with third. if you are not enclosing them in begin and end, which is kind of important thing if you are from Oracle background. You just first execute something in Oracle and then you will analyze whether the statement is correct or not. If it updates some 100K records or 20K records, 30K records, you realize you missed your where condition and you just roll back it. Postgres doesn't allow you to roll back if you are not putting in begin and end. I'll put begin, update something, roll back, it will work. I don't put my transaction in begin, I'll try to roll back, it will not work. Is this clear? Hello?
Yes,
So
yes.
in Oracle, there's auto commit, right?
Oracle is not auto commit by default. You have to explicitly execute commit statement.
Okay.
But here it is auto commit. You need not write commit statement again if you are not putting that transaction in, if you're not putting the statement in
Auto-commit,
begin.
why should I use begin to
Yeah.
start a transaction? Then any transaction arrive will just auto commit and it will say automatically.
Correct. And don't forget to put don't forget to write this begin before you just start any transaction. There is no discussion about consistency. As I said, yeah, as long as your database satisfying atomicity, it should be consistent. Third one is isolation. Postgres achieves isolation with the concept of MVCC. MVCC is a multi-version concurrency control. PSQL, select star from employee. I have 1300. Begin. I'm marking the start of the transaction. Then update employee set salary equals to 100 where ID equals to 1. Enter. What happens here? This is my 1300, my data. When I try to update this, the first thing that happens is copy the data within the table. 1300. And this data is for selects. I log in, select star from employee. I got 1300. This is this. And this is considered a star, which means no other session should touch this. It is exclusively locked. Now, since it is update, it will be modified to 100. Now, when I commit it, as soon as you see commit complete message on your computer screen, this is marked as dead. The star will go away. Now you execute the same thing, you see 100. Select star from employee 1,100, 1,100. I'll try to update, begin, change it to 200. The first thing that happens is copy the data within the table. 1,100, then you modify it 200. I have not committed yet. At this point in time, I have two versions of the same record. multi-version. If concurrent session is trying to access your data, it is controlled. So your session 2 will see this. Session 1 will see the latest information, 200. Because you're already in the same session that is executing the change.
Now, let's say if something happened to the server right now, right?
One, your voice is low. Two,
Okay.
it is breaking.
Let's say something happened to the server right now. Then session 1 reads, or let's say the server is down, right? Or you have an electrical problem and the server is down. Both session 1 and session 2 goes down, and when it comes up, will session 1 still see 200? It will reverse back to 100. Am I correct?
No. Your session 1 gone, session 2 gone. Both are gone if there is a power failure. And when you start it again, what is the consistent past image? This is the consistent
100.
past image. So both the sessions will see the consistent past image. If power is down, sessions are gone, right? You have to create a session, new session. Right. So Postgres achieves isolation with the concept of multi-version concurrency control. Multi-version concurrency control means you will have multiple versions of the same record within the table for the concurrent access. If you are trying to modify a record, it will take a copy of that record first, and then it will start modifying the data. That copy of the record is used for read workload that is happening during the transaction change. If you commit it, then the previous copy is marked as dead, no longer visible to any other session. For example, I'll commit it /tt plus I have a table of size 128 MB. Now I'll try to update this table. Now begin. Update table set something equal to something. I'm not giving the where condition, which means I wanted to update the entire table. Right, my update completed. Now I'll come here and see what is the size of my table. It is exactly doubled. Why? There is a transaction I made. This transaction has 128 MB of past image and 120 MB of ongoing image. (128 MB). Update entire table, take a complete copy. Now let us say I'll commit it. Come here and see 256 MB. Since I've committed this, the past image is considered as dead. This is dead now. No longer visible to any session. This should be visible. And in Postgres, grep Postgres, there is something called auto vacuum. This process does this cleanup activity of your dead records. So currently this table has 128 MB of dead records. This process comes and clean those dead records. You can manually clean them. We'll understand more about vacuum later, but let me, where is the clean command? I got to 128 again. Question.
If during the vacuum, the table still can accessible?
No. During the vacuum, to reclaim your space, table cannot be accessible. During the vacuum, if you are only doing cleanup activity, it can still be accessible.
Sorry,
I mean,
didn't get
if you are new to PostgreSQL, for example, vacuum does two things. Let us say I have 1,100. I want to modify it. What happens? Take a copy within the table. Now you modify it. This is marked as dead. At this point in time, vacuum can happen in two different ways. One, just to clean the record. Number two, clean plus release the space to operating system. If you are doing the first activity, then it will not take any lock. If you are doing the second activity, it will acquire a lock. I'll do it again. PSQL. I'm updating something. It is getting updated. What happened? DT plus. I got 256 MB. This time what I'll do, I'll just simply do this command, vacuum, my table name. Where is my table name? Teacher bench accounts. Vacuum completed. I still see 256 MB. But in my previous case,
vacuum full, you can.
Yeah. My vacuum completed, I still see, I have got the space reduced, but this time space did not reduce. So there is a difference between vacuum and vacuum full. Vacuum full means create table as select, seat as. Vacuum means just release the space, not release the space, clear the space, you retain your high watermark. In this case, your high watermark has not reduced.
But maybe in the end, right? Still, the table space is same. Means a huge die. Means, for example, is any huge table or whatever. Means there is a many transactions coming from the different applications. So the table, the growing is a very fast. You mean, if the table is a high used table means.
Correct. So periodically you have to do vacuum full if you think that the space consumption is more by your dead records. So generally what people do every 3 months, 6 months, once they'll do vacuum full on your tables. Vacuum is a maintenance activity. It happens round the clock. Whereas vacuum full, you have to manually do it. And if you think that your free space in the table is more compared to the live record space, then you have to do vacuum full.
So vacuum full means we need the down. Means
yeah, during your maintenance period, you have to do. Not maintenance. Yeah, during your downtime you have to do.
So there is no other way to avoid this vacuum full without downtime.
There are extensions, or there is an extension that does this activity. With the community version, there is no way.
Oh,
I mean, but with the default product,
Mm.
you cannot do that. You have to add some extension and then you can try.
thanks. Sorry, one more thing.
Hmm.
This automated vacuum, right? Just you say the vacuum.
Hmm.
Means is the by default it will do that one. We need to configure anything, or just it will go as a option.
By default, it will
But
do. How aggressively you want it to do the stuff is based on the parameters you provide. So in your P file, what you need to do, you need to add certain parameters or certain threshold limits for your auto vacuum to do this stuff. So let us say I'll tell my auto vacuum, do not touch this table until 1 GB of your dead tuples is accumulated. So
oh, that one we can configure by table level.
yes.
Oh.
And for example, in this case, it has got only 128 MB of dead records, or some amount of dead records which is not reached by 1 GB. So your auto vacuum will skip this.
But if the dead tuples is growing up, right? Maybe that will impact the application performance, database performance.
Obviously, yes. So when you do select star from employee, it has to bring all the data, all the blocks.
So you mean the day by day the performance will be decreased until we go to full vacuum or vacuum, right?
Yes.
Okay. This is same as in Oracle also. This is the way. Or?
No, Oracle achieves isolation with the concept of undo tablespace management. So what your Oracle does, you have 1,100. This is your user's data file. You want to update this. What it will do? First, it will copy of that 1,100 in your undo tablespace. This is undo TBS. You modify it here. And once your modification is completed, this can be overridden by other sessions. As long as your modification is not completed, but the other sessions needs your undo table space or the space in your undo, you'll get some snapshot to old error, right?
Mm-hmm.
So there is no concept of snapshot to old here because your past image is stored within the table.
So I mean the same location we are going storing in the Oracle is a different location. That's what
Yeah.
I mean.
Yeah, in the Oracle,
Physical
you have a separate table space called undo table space. You define some 10 GB of undo table space, 20 GB undo table space, right?
Yeah. Understood.
But here it is not the case. As long as your underlying mount point is free, there is no limitation here. So you want to update, let us say 1 terabyte of table completely. It will copy entire 1 terabyte within the table and do the modification. So there is no limit. Once it is done, this is marked as dead.
Okay. Thanks. Thank you. Got it.
I will spend some 2 days on vacuum activity. Vacuum is an important topic, both in terms of your day-to-day administration and in terms of your interview. I have seen 50 to 60% of questions asked in interview are on vacuum and then done. That's it. First question starts with vacuum. Yeah, go ahead, Suman.
Uh, during 1 terabyte of a transaction which is going on, okay, as a batch mode, during this moment, our table size grows double the size.
Correct.
Okay.
Obviously, you need to have underlying mount point space. to do this. What I'm telling is, as long as you have enough space in your hard disk, your 1 terabyte update will still continue and uses your 1 terabyte of your free space to store your past image or to copy the ongoing image.
Okay.
Yeah.
So, okay. That means it will, is there any surrogate key or something like that? It will mark the previous transaction as invalid and it shouldn't query that. When we query, I mean, it has to fetch the new records only, right? So if you want,
Information is stored in your data file header,
okay,
and it will tell the server process to whether to fetch the information or whether to touch the information or not. That information is stored in a pseudo column called xmin and xmax, comma star from employee.
okay,
Let's say I'll insert the data, insert into employee values 2 comma 200. Sorry, 2 comma 200. Let me run this. So 2 comma 200 is the actual data. These two are pseudo columns. This is the transaction ID that
okay,
has done this transaction,
okay,
or your SCN number. This is the SCN number. Now let me try to update the record. Update employee, set salary equals to 300, where ID equals to 1. No, 2. The number got changed.
okay. So if I read, it has to fetch me the latest record only.
Correct.
It will not fetch the old record, right?
Correct. The commit
Okay.
status or the transaction status of this record shows that this is the latest committed change. So it will read this one.
How it will identify? Because based on the Xmin, because there is no date timestamp, right? Which one is a
No,
later?
the timestamp will not work here, right? Based on the xmin only. This is the transaction status, based on the
Okay.
transaction status of that particular transaction.
Okay. So if I want to see the old history change of this data, so can we see?
Not possible.
We can't query.
No.
Okay.
Once it is committed, your old transaction or old data, you cannot read it.
But just now you have showed, right? This is my old.
I just
Okay. Until unless we use Xmin, Xmax, then we can't.
no. I just showed you that there is a pseudo column that stores your transaction information, and you can, I mean, Postgres recognizes it with xmin, but you cannot do that. See,
Okay.
there is nowhere you are giving it. It is giving you, right? See, I just updated the state. Where is the update? Yeah, this one. I updated something. The transaction ID got modified. 1351 became 1352, but there is nowhere you see 1351.
Okay.
There are I mean, there is one extension that gives you the past image data as well. But that is for your understanding, not for PostgreSQL. See, you want something like this. Assume you want to see your output of this query, something like this. 1351.
Yeah, that's right.
It is dead. You want to see something like this, you can still achieve that by adding an extension. And once your data is cleared, it will remove this. You will see something like this.
Okay.
Give me a second. Let me check if I. This one.
Okay.
What happened here? I've inserted 5 records.
Okay.
1, 2, 3, 4, 5. Then I used begin and end to insert 3 more records.
Okay.
So I've got 5 different transaction IDs for the first 5 records.
Yep.
But the last 3 records, I've got the same transaction ID because they are all done in a single transaction or
Okay.
in a transaction mode. Now, using this query, you will only execute this query after adding an extension.
Okay.
I've got 8 records. I got some raw data. Now I'll update something. When I updated it, you got this.
Okay.
Is the past image. This is the new image.
Okay.
See here, ID 8 I have updated.
Okay.
So this is ID 8.
Okay.
Its new image is this.
Okay. So how many versions, I mean, it can maintain?
Unlimited.
Unlimited. Okay. But it's unlimited, but they this value, right? What we can say, this numbering system, there should be some limit, right? Because it's keep on increasing, right?
Okay, I'll give you limit 2 billion.
Okay. So if it, okay, there is no limit at all for this. Okay.
As long as you are not reaching this 2 billion, it can store as many versions as you have. So when querying this table, it understood that this is the past image, whereas this is the new image. This can be visible. This should not be visible. And its latest information is available here. So your server process will get this information instead of this.
Okay.
And when I vacuum it, okay, I have updated another one. So when I vacuum it, these 2 is free. The space is gone.
Okay.
Any further insert will try to reuse this space, 8 and 9.
Okay. Okay.
If you're not inserting, yeah, these 2 free spaces, they will be just lying there.
Sorry, sir. Further insert means in the same table you're inserting another new record, or you
Correct.
same the ID is equal to.
No. In the same table, whatever the new record you add, your Postgres will try to reuse the space or reclaim the space.
Reclaim the place. Okay. One more. This 2 billion, right? This 2 billion is a
transaction IDs.
Transaction ID limited for the before coming. Only the once is coming is always.
It is just in PostgreSQL. You can only use 2 billion transaction IDs. For example, select the XID underscore current. This is my current SCN number from $V database. When I checked, now my current SCN number is 1353. if I'm doing any transaction, the next transaction will get 1354. Insert into employee values 3 comma 300, and now select xmin comma star from employee where id equals to 3, 1354 I got. 1353 was my previous 1354. So whatever the transaction I do next will get 1355. ID 4.
But if it's the data, mainly data, it means you mean that it's never fill the 2 billion record, 2 billion transactions in a
No,
database.
no, it will. One of the important things in PostgreSQL, you have to always monitor what is the latest transaction ID that is used. So currently it is 1355, next 1356, and so on. You'll reach 2 billion. When you reach 2 billion, your database will be converted into read-only mode. So you cannot do anything in your database.
Then after that,
Not after that, you have to ensure that it is not reaching 2 billion. How you'll ensure that it is not reaching 2 billion, it's altogether a big discussion. We'll understand that during our vacuum session,
okay, yeah.
right?
So this the max, right? The x max, x min is a transaction ID. X max is a
A past
uh,
image.
past image of, okay. If zero means is a new one, non-zero means always the transactions happen that record. You mean like that, right?
Correct. If you are not, I mean, the next 2 minutes, you just ignore it. This is your block 1 comma 100, the first record, and the second record. This is how your data gets stored. 2 comma 200, and this is your header. You will have pointers or something like this.
Yes.
You'll have pointers something like this. Now you update your third record in Postgres. Update means insert and delete. So when I update my first record, update employee, set salary equal to 200 for ID 1, it goes something like this. 1 comma 300. This is marked as dead. And your 1 is pointing to this, right? It will redirect to this. So go here and redirect. As long as you're not vacuuming. When it is vacuumed, it will straight away get something like this.
Oh, okay.
If it is not vacuumed, it is a redirect. How it will redirect, how it will know that redirect should happen? Your Xmax or transaction Xmax. So that is what we have seen, right? Your select will first try to see that information is still at this location. But when it reaches here, it understands that the latest information is at this location. So it will go there. But the information is still at the same location because this is not modified.
So what we can say is, I mean, because of this redirection,
Hmm.
the read queries will have
Suffer.
response times, bigger response times.
Suffer, yes.
Yep.
This
That's why we need to do vacuum. Okay.
that brings up to the question asked some time back. When you have too much, you call it as a blot.
Okay.
When you have
Flow.
too much blot in your table, then your selects will suffer. Right. And yeah, as I said, vacuum is a very big topic. One of the vacuum activity is to recycle these transaction IDs. So how this transaction ID recycling happens, all that stuff we'll understand during background processes discussion. As this number is getting increased, and if you are approaching your 2 billion, what you need to do is you have to recycle the old transaction IDs. So that you can reuse them.
So does the partitioning help to go beyond 2 billion?
No, 2 billion is fixed. That's an architectural number.
So is there any performance impact whether, if you do auto vacuum, it just, removes the dead records, but doesn't free up the space, right? So freeing up the space, I mean, obviously you'll get the space, but does it have any performance impact, without, doing the vacuum full versus vacuum?
Yes,
Okay.
you still see some performance impact. For example, your block has, this is my block
Okay.
with 8 records, and I've got 7 records removed. Only 1 live, the other are dead.
Okay.
Now, when you try to select something, it has to bring entire data. The complete block has to be fetched only for 1 record. Let us say I have 2 blocks. 1 is live here, 1 live is in the second block. Select star from employee. To get the 2 records, it has to fetch 2 blocks. You got it right?
Yeah, got it. Thanks. Yeah.
When you do vacuum fill, both the records will be moved to single block because it is a create table as select. But still, it is fine to have free space in your blocks. You cannot always do vacuum full.
Yeah, that's what I mean. If it is really very active database, with if your database is supporting multiple countries and stuff, it's hard to get the maintenance window, right? So
I mean, you need to rely on third-party tools.
okay.
Right. And the last one is your, what is the last one? Durability. Postgres achieves durability with the concept of write-ahead logging. Your Oracle achieves durability with the concept of redo logging. So any transaction you do will go to redo log or transaction log. The same way Postgres achieves durability with the concept of write-ahead logging. Your WAL file will be stored inside your data directory under this folder. And these are all my WAL files. As long as these files are there, you can take your database anytime in the past. Not ongoing database, that's a big activity, but yeah, you can still get the information.
This WAL file is nothing but is a transaction log in our regular SQL server or something, right? You mean?
Correct. Any transaction you do, the information will go into this file. And as long as these files are there, you can take your database anytime in the past. You call that something as point-in-time recovery. It's like telling your database to go back here because I made some wrong update or wrong delete here. As long as you have all these files, you can do.
So by time we can go by mentioning the time, something date time or how?
Kind of, yeah. You can mention the time or you can mention the X min value, something like that.
So if any disaster happen, right? Still same thing. Same way we can go to this file, WAL files.
What is disaster?
Something like is a breakdown. Sudden means it will instead of going the recovery means is a secondary node. We can retrieve from here.
No. You have to go to secondary.
Secondary.
Application, yeah, whatever the replication database, I think, right?
I mean, this
This is
not
only the
not not
RTO,
not
something like.
not an easy task. What
Yeah.
I'm telling is, as long as you have these files, you can some or the other way you retrieve your data. But that some or the other way is a complex activity.
Yeah, I think we experienced in Oracle once this whatever this file system, right? For specific what do you call tables, the file system that got corrupted, so we could not restore it because some of the table space, one of the table space got corrupted.
That is what you need
Yeah.
to do is in this case, for example, your data file is corrupted. What you need to do is you have to have one valid backup piece
Mhm,
and then all your redo logs.
mhm,
You take all your redo logs plus backup piece to some location,
mhm,
another machine, or in the same machine, it is up to you.
mhm.
You restore your backup, you apply all these walls to the backup,
Okay.
then yeah, you're back with your normal database. It's like restore plus recover.
Rec-
To do this recover, you need these wall files. So as long as you have the wall files, your database is durable. Right? How do we work with all these wall files and all this stuff is later. But yeah, just to recap what we have understood today. Postgres is RDBMS. In fact, it is Object Relational Database Management System. So if you are claiming that your product is RDBMS, you have to satisfy these two things. Postgres achieves ACID, A with the concept of begin and end, C there is nothing like that, I with the concept of MVCC, D with the concept of wall. Right? That's it from my side. Any questions? I'll take a session tomorrow. Tomorrow is going to be connection establishment. And from Monday, the regular discussions will start. Regular in the sense that these are all regular only. We'll
Well,
see
one thing.
we'll see installation on Monday, or vice versa. I'll try to do installation tomorrow, and then we'll see connection establishment on Monday. Someone, yeah.
Yeah, one thing. Do we have a weekend batches only for weekend?
No.
Okay. When those are going to be started?
It is nothing like that. As long as I have enough crowd, we'll see. I don't think so. I'll get enough crowd. Let's say
For weekend.
you're 20 here. By the end of the day after tomorrow, I'll have only 4 or 5.
Okay.
So there is no weekend session set up. The leftover 4 or 5, all they say, if all of them say we need weekend, I try to consider.
Okay. Okay. Yeah. Okay. Let's go with, I mean, what the people say, majority, whether we can have weekend sessions, at least max 2 sessions in one stretch.
99, not 99, 100% it will not be there.
Okay.
I'm sure. Mm. Chalo. Akim, I cannot hear you.
No, evening sessions also, right? As of now, this is only the one session.
Correct. We cannot hear you, Akim. Okay, yeah, that's it from my side. We will continue tomorrow, same time.
Okay. Can you share that the content? What are the topics we are covering?
Can you ping me
Sure.
offline in the
Yeah.
WhatsApp?
Okay.
Thank you. No questions, I'll wind up.
Yeah, thanks. Thank you.